Okay, guys. In the video, we are going to see another liquid problem. Problem number 199 binary attributes and categories related to scientific series. Category text medium. Okay, let's read the problem. Given the root of a binary key, imagine yourself standing on the right side of it. Okay. Then the values of the nodes we can see ordered from top to bottom. We have the binary inside the tree. Okay, we have the binary tree. So in that binary tree, we need to return all the elements that we can see from the right side. All right. So further, what is binary tree? Tree does not have linked with two children. Okay, if a tree only has left and right, or if tree only has left or right, not holding left and right, then it is binary tree. We are going to use the BFS approach. The BFS means a breadth first search. So it's a level by level traction. Level by level means first one, then two click, then five will be a first. In this example, we have a binary tree. So 1, 3, 4 are the right side views. So 1, 3, 4 is the output. We have another binary tree in the tree. We have one null and three. So the tree can be formed like this. Right side from this right side, we have can see only 1 and 3. So 1 and 3 is out. If it is null, we are going to return null. The range of the nodes from the binary tree is from 0 to 100 and values minus 100 greater than 100 less than or equal to 100. So node value can exist from this. Okay. So let's see the approach. First, we need to create a queue because I'll tell you in a moment why we need a queue. Then enqueue or store all the level by level data. So when I need to enqueue the queue with all the level by level data, okay, before going to next level, we need to delete the queue, right? So while deleting it, delete everything except adding lost element in an array or a list. In our case, it should be list. Okay, after all traversal, return the final list. Okay, so the example, same example 1, 2, 3, 4, 5. So we need to return 1, 4, 5 as the output. That's we know already. First, we have an initial queue. Okay, the initial queue is empty because we selected right now. Just now. And we need to offer root to that queue because for the initial queue, we need to give something. So that we are offering root. Root will be always seen from the right side. The root of the binary key will be always seen from the right side because it's the very first node. We are offering it. Q now Q equal to 1 and Q size will be 1. Q value is 1 and Q size is also 1. So before so the first level is completed. Once the first level is completed, we need to go to the next level. Before moving on to the next level, we need to add the last element of the queue in the list. Okay, as mentioned here, last element in the list. If size equal to last element. Okay, if size equal to last element means, let's say we have queue of 5 elements. The 5 elements, if we are going to call the first element, then we need to add it in the RES. So add the value in RES at lift of root first. Lift of root first because we need right side view. Q follows FIFO approach, which means first inserted will be first output. So, which also means the last inserted will be last output. Okay, so we need right as last element because that will be added in the final list. So we are adding right after that. If we add left first, right next, all the left element will be popped out first and the right element will be close to the RES. Right side will be close to the RES. Right side means the element which exists here. Okay. So queue size increases and repeated till queue is empty. So first the queue size will be 1, the next queue size will be 2, and next level and level queue size will be 2 again. So after that everything is null. So the queue will be empty and exist. So 1, 4, 5 will be returned. Let's see here level 1, queue will have only one element which is 1. Then we are going to offer the queue 2 elements, 2 more elements, first left, then another right. So left is 2 and right is 4. Before popping up the left, or polling the left, we need to offer the queue again left and right of the 2. So left is null, right is 3. So for level 2, queue will be 2 and 4, and 2 will be offered first. 2 will be offered first, so 2 will be removed from the queue first. Okay, the 4 is last, so first 1 will be added. The 4 is last element, so 4 will be added. Before polling the 4 and adding it into the array list, we need to offer elements of children of 4 to the queue. Left is null, and the left is null here, and 5 right side equal to 5. So for the level 3, the queue will be 3 and 5. So 1, 4, and 5 will be added to the result. So lost in, lost out. FIFO or EO, both of them are queue. So that's why we are following this order. Offering left offer first. So right offer last. In that case, we can add root or element of right in result. Let's see the code. It will be 1. So I have written the same tree here to explain the traversal. Okay. So first we initialize the queue, which is very important, and we initialize the list. It is going to save the result. Okay. So inside our right side view function, if root equal to null, written ODS, this is the third test case we have seen because the queue can be empty also as per the constraint. First initial opening, initially we need to do that because initially queue is empty, initial opening, queue dot offer root. See the first traversal. So initially first thing will happen, queue dot empty, no queue is not empty, it has one element. Queue dot size, so size equal to 1, and we are getting into the for loop for I equal to 0, I less than 1, I plus plus. Okay. And so inside the for loop, we are getting into the for loop here. Tree node current equal to q dot pool. So we have a current element there, q dot pool. The element will be node 1. Okay, here it is node. We need to mention it as node, not the element. I equal to size minus 1. Okay, here I is 0, size is 1 minus 1, 0, true. So this condition is true. So result dot add current dot value 1. It is important. We are adding result dot add 1. So one element is added to the final result, and it is the root. Next, if current dot lift not equal to null. So current is 1. This element is done. We have this element. Current dot lift not equal to null, and current dot q dot offer. So in q again, q dot offer 2, and again q dot offer right is 4. So we are going for second traversal. Here q equal to 2, 4. Okay, and RE is equal to 1. Again, the q is not empty. So the queue is not empty. It will go on again. So queue size will be 2 now. Current equal to q dot 4, which means current equal to q dot 4. So the current will be in 4. Current will be in. Okay, my bad. Current equal to q dot 4. Okay. So current equal to, in this case, it will be 2 because 2 is operator, so it should be denote first. If I equal to size minus 1, no, because right now the cube size is 2. So the value not equal to 1. Okay, so this is what happened. From 2, the queue size will be increased. First queue is offered first, then left and right of 2 will be added. Here, left is null, so 3 will be added. Its current will be here, 4. Okay, so 4 will be offer 4 will be called in the queue. Okay, if size equal to 1 not equal to 1. Sorry, 1 equal to 1. So in RAS equal to 1, 4 will be added. Next, current dot left not equal to null, Q dot offer. Here, 4 left is null, 4 right is high. So see the Q, we have 3 is already there, 4 is bold. So left of 4 is null. So right of 4 is 5. Okay, so Q size will be updated to 2 again. Now the current will be 3. Okay, so result dot add current dot value is 2 not equal to 1. Okay, not equal to 1. In that case, current dot left, no, it won't execute, it won't execute. So for loop will execute again. This will happen. So 2, 4, 5 will be added. 1, 4, 5 will be added. This is a simple problem to solve based by solved using recursion and behaviors. Keep watching for next videos. Thank you. Subscribe the video. Subscribe the link. Subscribe the channel in case you want another videos also.